Today we're going to learn about nth roots and rational exponents. The term under the radical symbol is called the radicand, and the term outside the radical symbol is called the index. The index tells us the nth root of a. For example, we can have three different types of numbers that use radicals. The first group, the square root of 81 and the cube root of 27, provide us simplifications that are rational numbers, 9 and 3. But the radical can also represent irrational numbers like the square root of 7 or the cube root of 5. When we try to simplify these, we get numbers that are non-terminating, non-repeating decimals. And finally, something like the square root of -5 is an imaginary number, a topic we will cover in the next unit. Here's an example of the cube root of 8. It's read as the cubic root of 8. It can also be written as a rational, using a rational exponent. We have the 3, which represents the root, and you can remember that because the 3 is in the bottom, in the denominator of the fraction. And we can, 3 is in the denominator, so it's the root, okay? And the exponent, 1, would be the exponent that we would have under the radical. Again, this is the index or the root, and this is the power or the exponent. This is read as 8 to the 1/3 power. So it can be read as the cubic root of 8 or 8 to the 1/3 power. Here's an example, the 5th root of 8. It can be written as 8 to the 1/5. This can be equal to 2 to the 3rd. We know 2 to the 3rd is 8. And so we can say 2 to the 3rd to the 1/5 power is 2 to the 3/5. So we can rewrite the 5th root of 8 as 2 to the 3/5 power. 4 to the 27th. Let's look at how we can rewrite that or simplify that using rational exponents. We know that 27 is 3 to the 3rd, and we can raise that to the 1/4 power because the root is 4, so it's to the 1/4, which can be changed into 3 to the 3/4 power. One thing we need to discuss is determining how many real roots a radical has. Now, if the index is greater than 1 and a is a real number, meaning that the root value is 2, 3, 4, 5, etc., n is odd, then you have one real root. If n is even and a is less than 0, then you have no real roots. They're all imaginary. If n is even and a, the term under the radical, is greater than 0, then you're going to get 2 real roots. And if n is even and a is equal to 0, then of course the root is 0. And actually, even if it's odd, the root is still 0. Okay, so let's look at some example. N is odd, then 1/nth root. So, for example, the cubic root of 64 is simply 4. If n is even, this is the square root of -36, and a is below 0, or less than 0, then you're going to get an imaginary number, as we said before. N is even, and a is greater than 0, like the fourth root of 16, you'll get plus or minus 2. And finally, if n is even or odd, and a is equal to 0, any root of 0 is simply 0. So let's try evaluating some expression with rational exponents. When you multiply same base numbers, you're going to add the exponents. So if we have 3 to the 2/5 times 3 to the 1/5, it's 3 to the 3/5. This is nothing new. You can almost ignore the denominators and have 2, 1, and 3. Add 2 and 1 and get 3. When you divide the same base numbers, you're going to subtract the exponents. Nothing new to you. We've done this before. Notice 5 to the 3/4 over 5 to the 1/3. The first thing I did was get common denominators. And then 9 minus 4 is 5, which gives us 5 to the 5/12. Notice all the bases are exactly the same. And when you raise an exponent to a power, just like you do with regular numbers, you multiply the exponents. 6 to the 1/3 to the 2/3, you multiply 1/3 times 2/3 and get 2/9. So let's solve some simple equations using radicals. Notice this is one that says 2x to the 4th is equal to 162. So the first thing we're going to do is we're going to divide both sides by 2, giving us x to the 4th is equal to 81. Then we're going to take the 4th root of each side, giving us the 4th root of 81. Notice, because the index is even, then we're going to have a plus or minus answer. So our answer will be the 4th root of 81 is plus or minus 3. So here are some examples for you to try, and you can check your answers when you come in the school tomorrow. See you then.